Today's topic is going to be unit fractions divided by whole numbers from Unit 6. By the end of this lesson, you'll be able to divide unit fractions by whole numbers and represent the quotient with an area model. You'll know you'll have it when you can evaluate an equation and determine the correct quotient through a visual representation of an area model or a number line. Some vocabulary that's going to be important to know for this topic. First is unit fraction. It's a fraction whose numerator is 1. It represents one shaded part of a whole. So for example, 1/3, 1/5, 1/2, 1/20th. If the numerator is 1, it would be considered a unit fraction. A number line is a line where numbers are marked in intervals and used to visually show mathematical operations. Finally, an area model is a visual representation of a mathematical operation. So, when I divide a fraction by a whole number, there's a couple different ways that I can do it. First, I can put it on a number line. What that would look like is I create a number line that has a fraction on it, or it's divided with 0 as the beginning and 1 as the end, with fractional intervals in the middle. Then I find the fraction that I need. I'm going to split that by my whole number. I will continue to divide the rest of the number line into sections. And then I will shade one part of that number line. That will give me the quotient of my unit fraction divided by my whole number. So let's go ahead and let's take a look at what that would look like here. So I am going to create my number line with a 0 at the beginning and a 1 at the end. I'm going to look at my number line, or my denominator, and I'm going to divide my number line into that many parts. So since my denominator is 3, I'm going to divide my number line into 3 parts, creating 1/3, 2/3, and then when I get to 3/3, obviously since it's 3 over 3, that would be considered 1. Then I'm going to look at what I'm dividing that unit fraction by. I'm dividing 1/3 into 2 parts. Therefore, I'm going to, in every single interval, I'm going to create 2 parts in each interval. Now, you can see that I have created more sections on this number line. I'm going to count how many sections I have total now. 1, 2, 3, 4, 5, 6. Because I've created sections, or 6 sections, my new denominator is going to be 6. And because I'm looking at units, I'm going to say, okay, well, shading 1 unit, my numerator is going to be 1. So I know 1/3 divided by 2 is actually equal to 1/6, because I'm taking this section that is 1/3 and I'm dividing it into 2 pieces, looking at the whole number line. This is 1/3 and this is a third. So each time I divide it, I'm dividing it in half. 1, 2, 3, 4, 5, 6. That's where I get 1/6. So on a number line, I can divide that number line in order to find my quotient, or I can do it with an area model. First, I would divide the whole into the number of parts stated in the denominator, and then shade one of those parts. So here we have 1/3 divided by 4. I'm going to divide my shape into thirds, so 1, 2, 3 spaces, and shade 1/3 of that. Next, I am going to look at what I'm dividing those thirds by, which would be the number 4 here. And from top to bottom, I'm actually going to divide that into 4 spaces. 1, 2, 3, 4. I will count the total number of spaces, and then I will shade one part of it. That will be the area model visual representation of 1/3 divided by 4. So let's look at the same problem, but as an area model. So again, I'm going to look at my denominator, and I'm going to divide my shape into that many pieces. In this case, it is 3. And then I'm going to shade one of those pieces. This represents the fraction 1/3. Next, I am going to look at my divisor, and I'm going from left to right, I'm going to divide it into that many spaces, which is 2. So I have 1, 2. Now I'm going to shade one of those spaces. To find the quotient, I'm going to count the total number. So 1, 2, 3, 4, 5, 6. The total number of spaces I've created is going to be my denominator. And because I've shaded 1, I'm going to have 1 as my numerator. So 2 different visual representations, but I get the same answer. Please continue on for some extra practice, and I hope this helped.